Congratulations on completing the exercise. This was definitely a very comprehensive exercise and we've got a lot to cover, so let's jump right in. The first requirement in the exercise was to add a projector power on and power off button to our touch panel. I'll open up my touch panel file. In the last exercise we created a pop-up page called Projector Lift. Since we are now controlling a projector as well as a projector lift, I'll rename the page Projector Control. And I'll add two buttons to this page. I'll name them Proj Power On and Proj Power Off. Now, here comes the first decision you encountered. What channel code do you use for these buttons? Well, since the exercise called for you to use an Epson module, you know the module will follow Snappy. The Snappy channel codes for Power On and Power Off are 27 and 28. If you don't believe me, pause this video, open up the Snappy help file or Snappy AXI file and search for yourself. I'll keep the channel port number set to 6 and I'll assign my channel codes for each button. Remember to make sure the feedback is set to channel. We're done with the pop-up page, so let's close it. Now open up the Sources pop-up page. Let's also rename the Projector Lift Source Select button. I'll call it Projector. I'm finished with my touch panel stuff. I'll save my file and shut down TP Design. Before we begin writing our code, I want to reiterate once again how crucial it is that we are all working in a correct source code file. With no other source code windows open, I'll open my P1_exercises source code. The next requirement in this exercise was to rename our dvtp_lift device definition. I'm now going to call it dvtp_projector. Since we're now controlling a projector, this name is much more appropriate. I'll also update my comments. If you are following our advice and you are compiling along the way, hopefully you noticed what happened when we changed this device definition. You got a symbol not defined error. Because we changed the device name, we also have to change all references to that device in our code. Here's another helpful tip, how to use Find and Replace. Under the Edit menu, go to Find and then select Replace, or the hotkey is Ctrl-H. It's very self-explanatory. Type in what you want to find and directly under that, type in what you want to replace it with. You can find and replace them one at a time or replace them all at once. I'll do all at once. I'll compile again to make sure nothing got messed up. The next requirement was to download and implement the module for our projector. I've already downloaded the module from amx.com, and there's no need to show you how to do that again. I will, however, add it to my workspace. Right-click on the module folder and select Add Existing Module File. I'll change my files of type to Duet Module Files or .jar files. Select the Epson Powerlight 905 and click Open. I won't change the identifier, select OK. Hopefully you didn't forget to also add in the module interface document. Right-click on the Other folder, find the Epson interface document and add that as well. Since we already had an entire lesson on implementing modules and looking through the interface document, I'm going to breeze through this rather quickly. If you don't have a firm grasp on implementing modules, I would encourage you to go back to the lesson on modules for review. Let's define some devices for our Epson projector. We'll call the real device DV Projector. We said that it's going to be hooked up to the second RS232 port. Therefore, the DPS is 5001:2:0. I also need a virtual device to be able to talk to the module. I'll call it VDV Projector, and it gets 41002:1:0. Okay, now that my devices are defined, let's define the module. I'll scroll down to the Define Start section and add in my Define Module statement. Define module, single quote, the actual name of the jar file, close single quote, a unique name for this instance of the module. I'll call mine com_prj_1, open parentheses, the name of the virtual device, comma, the name of the real device, and close parentheses. And once again, I'll compile after all that work. The next requirement was to create the code for our new power on and off buttons on the touch panel. Let's scroll down to the very last event we wrote in the Define Event section. If you remember, we last wrote two button events for our lift up and lift down buttons, as well as two channel events that handled the feedback. Since we're adding two more buttons to this page, I think it will be much easier to handle all of our buttons in one single event. I'm going to comment out both of these button events for the lift. Instead, I'm going to create one button event for dvtp_projector, and the channel I'll use is 0. Now, I can use a conditional to evaluate which button was pressed. The event is going to be a push, and now I need to choose which conditional I should use. Since I'll be evaluating which channel was pressed, I'll use a switch case. My switch is going to evaluate button.input.channel. Inside my switch, I'll create 4 cases, one for each button. Let's do the 2 easy ones first. I just commented out the 2 lift button events. My first case will be btn_lift_up, and I'll copy and paste the code into this new case. The second case is obviously btn_lift_down, and I'll copy its code from the old button event. Excellent. Now we need to add 2 more cases. The projector power on button and the projector power off button. Do you remember what channels we used? Look in the module interface document, scroll down to the channels section, and right there it tells you channels 27 and 28 are used to turn the lamp power on and off. So, for our case statement, sure you can put in here case 27, like so. But I would rather use the snappy constant that's available. Open the snappy.axi file and do a search for video projector. Scroll down to find what constant they use for 27 and 28. It looks like PWR_on and PWR_off. I'll use those for my case statements. Okay, my button event is built. I'll compile once again. We can't yet put anything in our projector on and off case statements. The requirements in the exercise state that we need to use the feedback from the module to track the power status of the projector. Once again, look in the module interface document to see what sort of feedback is offered. Look in the channel section again. All the way down on the bottom, channels 253, 254 and 255 will tell you if the projector is warming, cooling, or if it's on or off. So, let's get right to it. I'm going to create a channel event for the feedback from the module. Do you remember what device the module will provide feedback on? The virtual device. And the channel that I'm interested in is all channels coming from the module, so I'll put a 0 in here. The event handler we'll look at is the on state, and once again I'll create a switch case conditional that will evaluate which channel triggered the event. What is it we are going to switch? Just like the button events, channel events also have embedded properties. Do a search for channel events in the help file if you would like to look at these. The property we are going to use is channel.channel. Now, we need 3 cases. One for the warming state, one for the cooling state, and one for the power state. Just like the button event, there's a snappy constant for these as well. They're called lamp_warming_FB, lamp_cooling_FB, and power_FB. Let's do the same for the off state of these channels. Our channel event is now built as well. I'll compile to make sure everything still looks good. We still have to track the status of our projector. Therefore, we need to create a variable. I'll scroll up to the Define Variable section and create a volatile integer variable and call it nProjectorPowerStatus. While I'm up here, I might as well create some constants that we'll use for the status. I'll create a projector off gets 0, projector on gets 1, projector cooling gets 2, and finally projector warming gets 3. Go back down to our channel event and simply set our variable. nProjectorPowerStatus gets projector_warming when the warming channel goes on. nProjectorPowerStatus gets projector_cooling when the cooling channel is on. nProjectorPowerStatus gets projector on when the power channel is turned on. And finally, nProjectorPowerStatus gets projector off when the power channel goes off. The two off cases for lamp warming and cooling don't need anything in them. Feel free to delete the cases if you want. I'll just leave them in here. Now that we are tracking the status of our projector, we can begin adding all the conditionals to our code. The first one was that the projector on command can only be sent if the projector was off. This is rather easy. Scroll up to our button event. Inside the case for our power on button, we're just going to check to see if the projector is off before turning it on. So we write if n-projector power status $projector off. If that evaluates to be true, we then simply pulse the virtual device for the projector channel 27 or PWR_on. The power off button is a bit more complicated. Look back at our interface document. It says for the warming and cooling channels that when channels 253 and 255 are on, the projector is in warming mode, and when channels 254 and 255 are on, the projector is in cooling mode. Therefore, we can't just check to see if the projector is on using channel 255, because both channels will be on when warming or cooling. We need to check if n-projector power status =projector_on, and not n-projector power status =projector_cooling, or n-projector power status =projector warming. So, if the projector is on and it's not cooling or warming, then we can turn the power off. Pulse VDV projector, PWR_off. Okay, let's compile again. We're still looking good. Now we have to worry about the lift. Remember, we don't want to start a fire by having the projector on while the lift is up and the projector is in the ceiling. We need to add a conditional statement that makes it impossible to move the lift up if the projector is on. I'll go up to my lift up button and I'll add an if statement. If the projector is off, I'll allow the code to execute to send the lift up. As for the lift down button, it doesn't really matter if the projector is on or off if the lift goes down, so we'll leave that alone. Another compile. Now, what would happen if the lift is up and someone turns on the projector? The last requirement is when feedback from the projector is received and the projector is warming, check to see if the lift is down. If it's not, bring the lift down. Scroll up to the two channel events we created for the lift state. We have a lift state gets 0 and lift state gets 1. Let's make this easier to read. I'm going to scroll up and create two new constants called lift_is_up and lift_is_down. Now we can replace the 0 and the 1 with friendlier names in our code. Let's use this variable. Scroll down to the projector feedback channel event. Under the lamp warming feedback, we need to add the code to bring the lift down if it's not already. Therefore, if lift state =lift is up, then add in the code to bring the lift down. And I'll do the same for the lamp cooling feedback. If lift state =lift is down, then I'll add the code to bring the lift up. Now, if the projector gets turned on, the lift will automatically come down, and if the projector gets turned off, the lift will automatically go up. We're just about done. The only thing left to do is add the feedback statements for our projector power on and off buttons. This should be simple for you now. dvtp_projector, PWR_on gets n-projector power status =projector_on, and another one for power off. While I'm here, let's change the feedback for the lift since we added a couple of constants. Instead of 0 and 1, let's use lift is up and lift is down. One last time, I'll compile my code and make sure I'm free of errors and warnings. That's all for this exercise. Save and close this code file. Next up, levels.